Good morning. Today we're going to be talking about how to write the equation of an ellipse from a graph. That'll be related to IXL section V4. This will come right off the heels of the last video you watched that Ms. Harris did about the parts of an ellipse. The center and the vertices and the covertices and the major axis and the minor axis. Those are all things she talked to you about. Oh, it's been such a rainy day today. The kids have just been staring through the window all day. If it gets any worse, we're going to have to let them in. How do you know that Santa is good at karate? It's because he has a black belt. All right, last one. What is a frog's favorite type of music? Hip hop. All right. So on to math. So we're looking at ellipses today. And so, an ellipse is like a circle, except for it's been kind of stretched or squished. When you look at the equation of ellipse, there's two different forms of the equation, which can be a little confusing, but it starts off with x minus h squared, and then always a plus. That's going to be over something, and then y minus k squared, that's over something. And so, of course, h and k represent the center of the ellipse. So, and because of those minus signs, we do have to worry about the sign switch. So that's something we talk about later. What goes underneath the two fractions is going to change depending on how the ellipse looks, whether it's stretched vertically or stretched horizontally. So if it's stretched horizontally, what goes underneath the fraction is half of the major axis. So if that's the major axis, then A is the distance from the center to one of the vertices. And so that's called A. So half the major axis, or the distance from the center to one of the vertices, and then we put A squared under x because it's going in the x direction. And then what goes under the y minus k squared is half of the minor axis. So if the minor axis is there from connecting the two covertices, then the distance from the center to one of the covertices is b, and that's what goes underneath the y, because it's going in the y direction. So the direction of the ellipse, the way it's stretched, will determine where a and b are, and then this is always equal to 1. So x minus h squared over a squared plus y minus k squared over b squared equals 1. So if the ellipse happens to be stretched the other direction, so our center's here. Oops. So our center's here. And then the x minus h doesn't change, since that's the x coordinate of the center. And the y minus k doesn't change, since that's the y coordinate of the center. And the equals 1 doesn't change. So the only thing that changes is what a and b are, since a is the distance from the center to the vertices, and the vertex is the one that's further away. So now a is the vertical component here. So since that's going in the y direction, it would go under the y value. And b being the distance from the center to the covertices, and the covertices is always the shorter of the two, the minor axis. So that would be b, and so that would go under the x value because it's going the x direction. So that's the only thing that changes between the two forms, but it's really not that big of a deal when you get into it. Just paying attention to the direction that you're moving lets you know where to put the numbers. So it's really not a big deal, and I'll show you how to work through that without stressing about it too much. But that's the form of the equations. So we need to figure out what h and k are, so the coordinates of the vertex, or sorry, the center, and then we need to figure out how far it is from the center to the vertex and how far it is from the center to the covertex, and then just make sure we put them into the right variable. So here's our first one. Start off with a simple one where we see that the center, is at 0, 0. And then the next thing we want to know is how far is it from the center to the vertex. So that's always the further to, so I see it stretched vertically. So my A value is 6. So just the distance from the center to the vertex, one of the vertexes. And then B would be the distance from the center to one of the co-vertices, which in this case would be 2. So B is 2. So writing it out real thoroughly, we'd say x minus 0, since that's h, and then square over something plus y minus 0 squared. Oops. Oh. And that's going to equal 1. And then since a is 6, we're going to square that, and it goes under the y because it's going in the y direction. And since b is 2, we're going to square that, and it's going to go under x because it's going in the x direction. But the simplest way to write that would be x squared, since x minus 0 is x, over 4, plus y minus 0 is y, so y squared over 36 equals 1. And that's the way you're going to type that into IXL. It's like this. And it gives you a button for fractions, it gives you a button for squaring, and it gives you a button for parentheses to use for all those things. So let's get to a different one. So what I notice here right off the bat is that the center is no longer on the origin. So I want to find my h and my k. So in this case, h is 0 and k is -2. Next thing I want to look for is a or b. It looks like this one goes further in the y direction. So as I go from the center here, it's from -2 to 5 is 7. And from here, from 0 to -6 is 6. So yes, it's longer in the y direction. So that would be my a value. Again, it doesn't really matter which one's A and B, just that you're writing them in the right place. This is 6. So there I have all the values I need. Again, I'm going to show you the kind of the long way to write it out, and then I'll show you kind of the simplified version, and you guys are want to be typing the simplified version. So x minus 0, since that's h squared, and then over, since b is going in the horizontal direction, that's going to be my what's under the x. And then plus y minus -2 squared. And then my a is going in the vertical direction, so I'm going to write that under the y, and that's always equal to 1. So the simplest way to write that would just be x squared, since x minus 0, over 36, plus y minus -2 is y plus 2 squared over 49. Equals 1. So that would be what you would type into IXL. On the next couple examples, I'm going to go straight into the simplified version, just to show you how you can do it faster, or kind of in your head, so without having to write it all down. So first thing I want to notice is where my center is. So that's at -4, 0. And then I want to see that this is longer in the x direction, so kind of counting what that is. So from -4 to -10 is 6 units, and then from -4, or from 0 to -2 is 2 units. So I see that my h value is -4 and my k value is 0. So x minus -4 being x plus 4. So there's that sign switch. We're going to square that in parentheses. And then that's going to be over, and then the 6 is the horizontal one, and 6 squared is 36. Plus, it's going to be another fraction. Then I have y minus 0, so just y squared. And then the vertical axis part here is 2, and 2 squared is 4. And then that's always going to be equal to 1. So that's kind of the fast way to write those, how to do that in your head. Make it a little bit quicker to go through the lesson on IXL without having to write it and then rewrite it. I'll do that one more time in the fast method, and then I'll do another example that's slower. Okay, so now when we see where the center is, again, just starting there. So my center is at -2, -3. Looks like this one's longer horizontally, so let's see how far that is. From -2 to -7 would be 5 units. And then vertically, going from -3 to -7, so that'd be 4 units. So fraction, and then parentheses, x minus -2, so x plus 2 squared. Then the horizontal change here is 5, so it's going to be over 5 squared, which would be 25. Plus, always plus, fraction, parentheses, so y, and then the y coordinate is -3, so that's going to be y plus 3 squared, over 4 squared, which is the vertical component. So 4 squared being 16, and that's going to be equal to 1 every time. So ellipses are always a plus in the middle, and ellipses are always equal to 1 when you write the equation. All right, one more example, and then I'm going to do this one in the slower way, just in case you need to see that again, and then we'll be done. We're going to start by finding that center. So in this case, it'd be -4, -1. And then looks like this one's definitely longer in the vertical, so this will be my A. So that's from -1 to 8, which is 9 units. And then here's the minor, or half the minor axis. So from -10 to -4 is 6 units. And the 9 would be A, and the 6 would be B. And this would be H, and that would be K. So we start off with the fraction, parenthesis, x minus -4, since that's my h value, squared. And then my b value is 6, where the horizontal component is 6, so that's going to go there and be squared. Always plus, fraction, y minus -1, since that's k, squared. The vertical component is 9, so it would be 9 squared. That's always equal to 1. So simplifying that would be x plus 4 squared over 36 plus y plus 1 squared over 81 equals 1. And that's what you would type into IXL. So not too bad. Going from the graph to the equation. Hopefully you have luck with that. And I bet you can't get 100% on this. I couldn't, so on this lesson. See if you guys can. But it is lesson V4 on the Algebra 2. Writing equations of ellipses from a graph. You need to get at least an 80, but I bet you can't get 100. So see if you guys can meet that challenge. And hope you guys have a good day. Take care.